I'm sure you have eaten something today. I definitely have. Now we tend to take the abundance of food for granted. But as the human population is growing rapidly, it has become harder and harder to feed us all. That's why we nowadays use nitrogen fertilizers in agriculture to produce food more efficiently. Now we have nitrogen gas everywhere in the atmosphere, but sadly few plants can directly use it. We therefore first need to convert it into another form of nitrogen, positively charged ammonium, which is something that plants love to feed on. Nowadays, this process alone feeds half of the human population, which is amazing. But unfortunately, the process also uses up to 2% of all energy consumed in the world, which is a lot. Also, this energy is produced from fossil fuels, so it's not sustainable. So far, the use of nitrogen fertilizers has also been very linear. We use them to grow food, we eat the food, and then use the bathroom. There, we flush a lot of the nitrogen down the toilet, and it's taken to a wastewater treatment plant. Up until this point, most of the nitrogen has remained in the form of ammonium, so the exact same form plants use to grow. But at the wastewater treatment plant, ammonium is converted back to nitrogen gas and released to the atmosphere. This again requires a lot of energy. In other words, we are wasting energy, going back and forth between these two forms of nitrogen. It's clear we need a more circular approach. So we have plenty of nitrogen as ammonium at the wastewater treatment plant. I say we should recycle this ammonium back to agriculture instead of producing new fertilizers. And what if I told you we've developed a process that could recycle ammonium with up to 90% efficiency? Indeed, we have. A novel electrochemical process. In electrochemistry, we make use of the positive charge of ammonium. This charge makes ammonium react to electric fields. When we apply a negative electric field, it works like a magnet. The positive ammonium is drawn to it. But we can also stop the ammonium with a positively charged barrier that will repulse it. With both positive and negative electric fields, we capture ammonium into a liquid fertilizer. And the best news is, we don't need to use any chemicals, unlike in other nitrogen recycling processes, such as stripping or struvite precipitation. We only need electricity, and it can be produced from renewable sources. So this innovative electrochemical process is one step closer towards a closed nutrient loop, which will secure sustainable food production in the future. That's something to think about the next time you're sitting on the toilet. Thank you.